quick review of yesterday's material, 7.3. Okay, just really fast. Remember, logs are opposites of exponents. They undo exponents. They're the actual inverses of exponents. Okay, and we can take the form of y equals b to the power of x in exponential form, and to write it in log form, you take that base. Let me write that a little bigger. If you have this, you take whatever this base is, and as you move it over to this side, the goal is to isolate x. By moving it over and taking the log of whatever this is, you then make x, you take x out of the power position. And that's something I guess we didn't focus on enough in here yesterday. X moves out of the power position when you move that base over and take the log of that base, or log base b of whatever's on that side. Okay? So as we move this over, it becomes a log with this base. We're taking that log of this value, and the x is now isolated, so we can solve for x. Yeah?
Would that be because when you move b over, there's still a 1 there, and so it would be 1 to the power of x? Would that be y?
It's not really y, no. No, it's just by taking the log form of this, it brings the x out. Okay, it's doing the inverse of an exponent. So by doing that, it allows us to figure out what that value is. Okay, there's trying to figure out the math, like trying to rationalize. Yeah, it's because it's 1 to the power of x. It's a little tougher than that. Okay, so right now, just understanding how to go from exponential to log form is kind of the important piece on that. Okay? All right. Tell your neighbor what a common log is. Okay, volunteer. What's a common log? Hannah?
Anything with a base of 10.
Base of 10. Common log is a base of 10. We talked about that yesterday. Now, whenever you use your scientific calculator, or most calculators that just say log on them, they are calculating in base 10. Now, we know that there are tons of different bases. There could be base 3, base 1/2, base 2. There could be infinite number of bases. If you have log base 10, that's what your calculator is calculating in, unless you use the actual log feature. There's a different feature where you can change the base on your calculators, on most of your calculators. Now, when we do our tests, you won't be able to use your graphing calculator on portions of it, so you better learn the properties of logs. Okay? All right. Special cases, log base a of a equals 1, and that's because if you rewrite this, if you bring that log back over, that a becomes your base, and that 1 moves up to the power position, and we get a to the first is a. Okay, so if you take a log base a of the same number, if the base and this number are the same, then your answer is 1. It's easier to see that in exponential form. So part of what we do today, we'll be able to move from log to exponential and from exponential to log form. Okay, we need to get in that habit. Once again, if we have log base a of 1, that equals 0. Or excuse me, log base a of 1 equals 0, because when you move this over, a to the 0 power, move that base back over, is equal to 1. Anything to the 0 is 1. So we're using those properties of exponents there. All right, questions up to there. That's where we stopped yesterday. That's really, really fast review. It'll hopefully make a little more sense as we progress if you're struggling there. All right, common bases. We're going to change to a common base to solve this. So if I say log base 8 of 16. Now, if you have and you know how to use your calculator to calculate this, the goal is not for you to use your calculator. So just put your graphing calculators away right now if you can't resist. Like if you can resist going to that place where you can do this on it, then that's fine. Otherwise, just put it away. Okay? Now, to change to a common base, we want to start recognizing that 8 and 16 can both be changed to a common base. Okay, the way we're going to do that, first I'm going to rewrite this in exponential form. So right now I want you to rewrite this in exponential form, please. So some of you are like, I don't know how to do that. You're just starting out. How many of you were able to, you think you did it? Okay, so what is the base in this? That's the first question to ask. Jaden?
The base is 8.
The base is 8. Everyone agree base is 8? Yes. Okay. Base is 8. That means when we go to exponential form, the only base you see is your b term. remember the form y equals abx? We're going to kind of ignore the a and just think of y equals b to the power of x. Think a is 1. Okay? This is our base. All right? Well, if that's our base now, when we write it in exponential form, we want our b, so we'll ignore the a. Okay? We want our b to be 8. So as we move this over, you got it. If you're trying to think of like what we've been doing with equations where we move things across the equal sign, if we move that over, that ends up being 8 as our base and x as our power. And that equals 16. Everyone with that? 8 to what power is, how many got it right first? 8 to what power is 16? First power? First power is 8. Second power? Second power is what?
64.
64. So somewhere in between 1 and 2. Well, what we could do is we can go to a common base. This is not a common log. Common log is base 10. Okay, that's different. We're doing a common base. That means it has the same base. Right now, this is base 8. This is base 16. This is 16 to what power?
1 first.
That's 16 to the first. So if we think of 16 to the first and 8 to the x, if we can get the same base, then we'll know the powers. Right? So, and you'll see that here in a minute. What base, will multiply to make 8 or 16? Start thinking, like 1 times 1 times 1 times 1. Anytime you multiply by 1, you're going to get 1. 1 doesn't work. Let's try 2. 2 times 2 times 2 is 8. So we could think of 8. We can substitute that as 2 to the third. Let's write it as base 2. And the only reason I do that is because I already know that 16 is 2 to the fourth. That's why I'm using base 2. So I substituted 2 to the third in for 8. What else should I have over here still?
The power of x.
The x. And over here I have 16. I substituted 2 to the fourth in. Do I need that 1?
No.
Not really. Okay. So I have 2 to the fourth. Okay, so that's really small. Just tell me to zoom in there. Okay. I have 2 to the fourth equals 2 to the fourth equals 2 to the what? 3x. Notice my base is the same now. So if these two expressions are true, like if this is equal to this, if this is a true equation, if this expression equals that expression, the only difference is this portion of it, the 4 and the 3x. Since that's the case, all we have to do is say, when does 4 equal 3x? Okay. What is x?
4/3.
X is 4/3. So if you went back to your original problem, this, you changed to this. If you on your calculator said 8 to the 4/3 power, that's a little over 1, you should get 16. Everyone with that?
Mm-hmm.
Yeah, man. Yeah.
I'm kind of confused on how you went, or actually, never mind.
Okay. All right. Try that one. Write it as a common base. First write it exponentially and then try to come up with a common base. Hey, how many got it to exponential? Or you think you did? Okay, what base are we? Base 9. We're going to move that over. That base now becomes 9 and power of x equals 243. Okay, how many made it that far? Okay, and so from there, 9, hopefully you recognize 9. The only other base 9 could be is 3. So that's 3 to the second to the power of x. Now I'm just assuming that 243 is base 3 also. So 3 to what power is 243? Fifth. 3 to the 5th power. How do you know that? Well, maybe you have your 3's memorized. Like I actually do know that. Okay? I don't expect you to have that memorized. However, at some point, you may memorize that. Okay? If you don't know that, you just start guessing. 3 times 1, 3 times 2, 3 times 3, 3 times 3 times 3, and 3 times 3 times 3 times 3 times 3. You keep doing it until hopefully you get that or you pass it, and then you're like, nope, it didn't work. Okay? So the equation we end up with, 3 to the 5th equals 3 to the 2x. So the only part now that is different is that and that. Therefore, if this is equal to that, then 5 would have to be equal to 2x, meaning x would equal 5 halves. How many got that? All right, ask your neighbor if they have a question on it. That's pretty early. Okay, questions? Okay, hey, just really quick, this has nothing to do with what we're doing in terms of this. However, if we plugged 5 halves back in here, that would be 9 to the 5 halves. You don't have to do this, but just really quick, a quick review. How do we write that? What's another way of writing 9 to the 5 halves without the answer? It's another way of writing that some of you struggled with. Let's see if you remember. Okay, the numerator is our power, 9 to the 5th. Denominator goes out here. That's what that means. So you could do the square root of 9, which is 3 to the 5th power, which is actually 243. We figured that out. Pretty cool. Okay? It's just a quick review on that. This is what we're looking for here. Okay, everyone should have their assignment. Let's take a look at it and give you what we're doing today. All right, so you're not crossing things out today. We are going to be working off the example side. We're going to do some of these together as a class. Your actual assignment, let's find my sheet here. Your actual assignment is 1 through 32 plus 45 and 46. Example side, 1 through 32 and 45 and 46. I will tell you, the assignment goes much faster than it appears. When you're looking at it going, wow, it's like 32, 33, 34 problems, man. Okay, well, if there's 34, I know that it's going to go faster than you think. Okay? I have numbers 45 and 46 on a different handout for you, so it has graphs on there and everything. We'll work through some of that. Okay, so let's try some of these right now. Look at example 1. We'll zoom in there. Okay, example 1, write each equation in logarithm form. That's what you're doing. I want you to try 1, 2, 6, and 7 right now. So if you're doing this on a separate sheet and you have a hard time going out of order, leave a place for number 3, 4, 5. Okay, as we skip those. I want you to try 1, 2, 6, and 7 on your own. Yes?
Can we do it on our note sheet?
You could, yeah.
Okay.
Yeah, you could do them on your note sheet. Okay? Check it out. 2 to the 3rd. You might not have them all done, but let's make sure we at least have this here. 2 to the 3rd, if I'm writing it in log form, remember, I want to identify the base. It's all about the base, right? Okay? And move that over. So we get 3 equals log base 2. So as we move that over, that becomes a log base 2 of 8. Okay? Now you should ask yourself, is that true? And think about base 2. If you're at a base 2, 2 to what power is 8? 3. So yeah, dude, that's true. Okay? That's the other way to think about these. Once you're done, that's your check. This small number is your base. So you say 2 to what power is 8? And that's 3, just like we had here. Make sense? This is your answer. I mean, that's changing it. Right here, you're just practicing changing them. Okay? So we move the 3 over, identify that base, move it over. We get log base 3 of 81 equals 4. Is 3 to the 4th 81? Yep, we're good. Questions on those two? Everyone rate themselves 1 to 5. That's a key right there. All right. Now, you guys, as you're going through this, if you are someone that sometimes goes, well, I'll catch on eventually, the new stuff just keeps piling on here. So if you don't get this, you really need to ask for help. Okay? All right. So this next one, we got the -3 there. doesn't change anything. We still identify the base and move it over. So now we're left with negative 3 on that side, and log base 2 of 1/8. Put that in parentheses. So is 2 to the negative third power 1/8? It is. Okay. Questions with the negative there? Not a big change, just it's negative. This one then is 2/3 equals log base 27 of 9. All right. We got it? Okay. Give yourselves about 3 more minutes to do as many as you want on 1 through 8. Okay, if you're done with 1 through 8, you can look at 9 through 20 and see if you know what's going on there. That's the next piece we will be going through. Questions come up? All right, let's take a look at the next part. Now we're going from log to exponential. All right? So number 9, what's my base? 2. Identify the base. So as we move this back over, we now are at 16 with a base 2 to that power. What happens if you don't see a base?
Base 10.
Really? Yeah. It's 10. Yes, so this is a base 10. Okay, so if you don't see a base and it helps you to write it in, go ahead. But if you don't see a base, it's base 10. Okay? So go ahead and try that section. I'll put these answers up here in a minute. If you need help, raise your hand as I'm walking around, or stop me. You guys are pretty bright. You're flying through it, so I'm going to put these up. Make sure you've got them. Okay? So number 10 should be 1/27 equals 3 to the negative third. This one here, as we move that log back over, that becomes 100 equals 10 to the second. Our base is 10. And number 12, as we move that log, that's base 5, so we get 125 equals 5 as our base, 5 to the third. Good? Dylan?
So, like, when you come across ones that are like, puts in the zero power, do you need to like simplify that? Or
No, you're right now in the, like, are you talking 15?
Yeah.
Okay, right now all you're doing is trying to go back and forth between the two. That's what you're practicing in those top sections.
Okay.
Okay? That's good you recognized it. All right, let's move on to example 2. Okay? How many have finished example 1? You guys are flying. Notice, man, now you're done with the first 20 problems. That's ridiculous. I should have given you more work. Okay? Evaluate each log. So I'm going to talk about 2 different ways here. First way is looking at this and going, well, if I'm evaluating, I'm trying to figure out what log base 4 of 16 is. I could just think of that as saying, well, I don't know what it is, so it equals a variable. It equals x. So you could just add a variable at the end. And by doing that, you can now write it in exponential form. If you don't know how to do it in log form, change it to exponential. Okay? So if I move that over, that says 16 is equal to 4 to the x power. Now most of you know what that answer is. What is it? 2. The solution here is 2. The other way to think about it, and I'm hoping you eventually move to, rather than having to write that, is where you look at a problem like this and you go, I know this is my base. I know it's going to come down to something like this. So really I could say like 4 to what power is 16? 2. 4 to what power is 4? 4 to what power is 1? 0. Now, if you're struggling with that, if you're going, whoa, he just completely lost me right there, then practice for now by saying that equals x, write it in exponential by pulling that over and saying 4 equals 4 to the power of x, and then you got 1. Or set it equal to x, bring it over, 4 to the power of x equals 1, so therefore x is 0. Okay? So if you think you might have it, try number 24. I know you may not be there. Some of you are already there. Some of you are past there. But try 24. Hey, so this one, if you're setting equal to x, and then you bring it over, remember that's going to be 256 is equal to 16 to the power of x, which in that case, x is 2. Okay, or you could say 16 squared is 256. Any questions on that section? All right. Now, how many of you finished through 32?
Almost.
Man. Hey, we're getting close. So at that point, you really have two problems left, 45 and 46. And the portion that we haven't talked about is how to graph logs. Okay? Now, I just handed back your exponential graphing portfolio pages, and most of you are doing really well. Just a few things for some of you to get fixed up. Remember, those are due on Tuesday. You're going to get your log one next week sometime. And the log one is actually pretty easy. The harder part becomes the properties. But for graphing them, these are the steps I would suggest doing when graphing. Okay? Did I put this on the back of that page? So it might be it's on the back of your graph page I just handed you. Okay? Or the girls passed out. So first, write the log in exponential form. Why? Because it's easier. Do you have to? You don't have to. You come up with your own way. That's the easiest way I find. Second, create a table of values. The key here, choose values for y. And then solve for x. And then graph. Now this is how I graph them. Now if you have a super duper math person you live with and they have a different way and it works for you, fantastic. This is how I graph them. I find it beneficial. Okay? So if I'm graphing, say, 45, first thing I am going to do is what? Write in exponential. So everyone write that in exponential form. Hopefully that's something you can do real easy now. This one might be a little weird. This is a base 10. And note, when I write it in exponential form, I move that over. I now have 10 to the y equals x. Now that is why we choose values for y. Okay? 10 to the y equals x. So if I'm building my table of values, now I'm going to put mine right down here, and I have x and y. Okay, and I have 10 to the y is my input piece there. And I'm picking values for y. If I want to find the x-intercept, what am I putting in for y? 0. It's kind of like your exponential, but you're just going the other way now. So I put 0 in, I get 10 to the 0 equals 1. Okay? Now remember, a log is an inverse of an exponential. That's why that seems different, right? X and y are switched around. Good, so if you finish your table and plot all your points, notice the 100 doesn't fit. But you finish your table and you plot all those points, you get it infinitely close to that x-axis. You never actually touch it. Now remember, like I said earlier, this is the inverse of an exponential function. Remember, an inverse is a reflection over this line right here. Now this is not part of this problem. We finished the problem. But just to expand it so you can relate it to what you already know, that is an inverse of, I'd have to switch those values around, right? So this, if I take and find the inverse of it, I would now have 10 to the x equals y. Inverse is you just switch x and y's, remember? 10 to the x equals y. That's the inverse. So, not part of the problem, but so you can relate it, this point that was at 1, 0 would now be 0, 1. And this point that is at 10, 1 would now be at 110. And these would reflect accordingly. And the exponential of this would look like that guy there. It's a reflection over that line. Okay? How many got how they tie together? Okay, it's important to be able to chunk the math together. That's why we do that. So that now you're not going, well, it's logs and it's exponentials. It's logs and exponentials together. You should be able to see the relationship between the two. Okay? Any questions? You have one problem left, most of you, number 46. Okay?